All right, good afternoon, everyone. Welcome to the second talk of the CRELS Spring Speaker Series. CRELS stands for Computational Research for Equity in the Legal Systems. We're a National Science Foundation research training program, and our goal is to train PhD students in the social sciences, professional schools, statistics, and computer science in multidisciplinary research on the criminal legal system that leverages new data science methods and considers the ethical and social implications of big data and artificial intelligence. Before I start the introductions, I wanted to announce or remind folks of our call for applications for the next cohort. It's out online. The deadline is April 29th, and you can find the application on our website. If you just Google computational research for equity in legal systems, you'll find our website. And if you have any questions, you're welcome to contact our executive director, Dr. Harpreet Mangat, at bids-crels@berkeley.edu. Today's talk is titled Shifting the Frame, the Labors of ImageNet and AI. Before I introduce our speaker, Dr. Alex Hanna, I want to thank the Matrix team, Professor Marion Fourcade, Julie Cizik, Chuck Kapelke, Eva Cito, and the student support team. We're also grateful for our co-sponsors of today's talk, the Department of Sociology, the Berkeley Institute for Data Science, and the Criminal Law and Justice Center. And I also, it's not written on my paper, but I also want to thank Harpreet for all her work in organizing this event. Dr. Alex Hanna is the Director of Research at the Distributed AI Research Center, or DARE. A sociologist by training, her work centers on the data used in new computational technologies and the ways in which these data exacerbate racial, gender, and class inequality. She also works in the area of social movements, focusing on the dynamics of anti-racist campus protests in the US and Canada. Dr. Hanna holds a BS in computer science and mathematics and a BA in sociology from Purdue University, and a master's degree and PhD in sociology from the University of Wisconsin-Madison. So please join me in welcoming Dr. Hanna.
Thanks, Professor Harding. Thank you to everybody at CRELS for inviting me here. Happy to give this talk. Sorry I had to change the schedule a little bit. I've got an appointment I need to run to right after this, but I am happy to take questions or anything over email or Twitter or Mastodon or whatever you want to. I'll have all the details on the last side. So the name of the talk today is Shifting the Frame, the Labors of ImageNet and AI Data. And it's part of what I hope to be a book manuscript around ImageNet, in particular thinking about all the labor that is involved in the construction of AI in kind of multiple registers, not only labor involved in data annotation work and building different types of infrastructure, but also the ways that there's a significant strain of cultural labor involved in the maintenance of what this is as an artifact and something upon which AI is built. All modern AI is built, I would argue. So I want to start off with a discussion of the data itself, which, according to Martha Birdstern in this article written in Quartz, an interview with Ifefe Lee, now the director of Stanford's Human AI Institute, or Stanford HAI. And this was published, I think, in 2017, and it was titled "The Data That Transformed AI Research and Possibly the World." And it was about this data set called ImageNet. Basically, in a word, the current era of AI that we're in right now, the deep learning era in which models are becoming larger and larger, trained on hundreds of thousands of machines, GPUs, across the world, wouldn't really be possible if it weren't for ImageNet. We wouldn't be in the deep learning era if it weren't for ImageNet. And there's some discussion of this with Dr. Feifei in the text of this article. In a word, what ImageNet is, it's a data set of over it's over 14 million images sorted into 20,000 categories. That was constructed in the late 2000s and early 2010s, and is regarded as a key AI benchmark, things on which AI is trained on, tested on, and evaluated on. To give you a sense of what the jump was here in ImageNet, prior to ImageNet, the largest image data set was called Pascal VOC, constructed by Mark Everingham and colleagues at Cambridge. And it had about 20,000 images in it with 20 categories, so scales of much larger. Scales larger than the current, that was current at the time. ImageNet's not the largest image data set. For instance, the Lion data set that has 5 billion text and image pairs is one that has been used for years for training many generative AI tools, was recently taken down for issues involving child abuse and sexualizing material. But it certainly set the tone for the type of research that Lion wouldn't really been able to have done if it wasn't for the methods used in the creation of ImageNet. The way that Dr. Fei Li talks about the adoption of ImageNet was that upon its creation, and I think completion in 2010, they developed a challenge upon which people could evaluate how well their image classification and object localization algorithms would perform on the data set. These tasks, so image classification is determining how well an algorithm effectively performs on classifying what is in an image, is that's the constraints of that task. And object localization, the task of drawing a green bounding box around an object and telling where it is in an image. OpenAI, when they were a bit younger and less known for their GPT tools, published this graph in 2018, in which they were showing effectively what the inflection point was, where deep learning really took over. And the ImageNet challenge was one of these points in which these spurred on this inflection. In this challenge, which ran from 2010 to 2017, there was entries upon which in 2012, a particular paper was published on this named AlexNet. AlexNet, no relation, developed by 3 people at the University of Toronto, Alex Krzyzewski, Ilya Sutskever, and Jeffrey Hinton. This paper, entitled ImageNet Classification with Deep Convolutional Neural Networks, won the ImageNet classification handily at that point. And it had become an inflection point for the use of these methods. All these methods now used in deep learning use some version of neural networks. Their research company, which was premised on an idea with no actual software, DNN Research, sold in 2013 at the NeurIPS conference for $44 million to Google, and could have gone much higher according to Hinton himself. Hinton himself went to Google to become a research fellow, reporting directly to Senior Vice President Jeff Dean. Ilya Sutskever is became chief scientist at OpenAI and sits on their board, and Krzyzewski has actually kind of sunk away a bit. Last time I checked, this paper had 125,000 citations. I don't know if this is the most cited paper of all time, very possibly. If not the most cited, probably very much up there. ImageNet still is widely used in different types of work. According to Papers of Code, it is the second most used benchmark data set, with over 10,000 papers and 102 separate benchmarks. It is used and has been used across years. It's not actually very slowing down. The statistics for 2023 is low just because the image is old, but ImageNet is still being used despite all the issues that we do know with it, which I will talk about in a moment. In a paper written with Bernie, and this is the graph on the right. In a paper written with Bernie Koch, a sociologist of science now at the University of Chicago, Jacob Foster, and Remy Denton and myself, we described the concentration of particular data sets. So for one, over 50% of benchmark data sets are the product of a little more than 10 institutions, a division between private and public institutions, including Stanford, Microsoft, Princeton, and Max Planck. And this concentration on the right with this Gini coefficient is going up over time and is becoming more concentrated across institutions. So a curious result is that data set benchmark and evaluation is becoming more concentrated across institution and papers and data sets across time, not less. In another paper written by myself, Remy Denton, Razvan Avaronesi, Hilary Nicole, and Andy Smart, we talk about how ImageNet has set the tone for how AI research is done. In particular, the fact that there's been an unreasonable effectiveness of data. And this is taken from a title that was written by a few folks at Google, including Eric Horowitz and others, but that there's been a replication of having ImageNet moments in different fields. This is from a slide that Dr. Fei-Fei Li has presented in different locations, including how ImageNet is now a mark of pride against different types of domains, things like ShapeNet, MusicNet, Medical ImageNet, and so on. And so this is a bit of a prelude to a three-part agenda of what I want to talk to today, which is about the different types of labor and hidden labor that have gone into AI construction, and the way that we can think about data sets and AI creation, not in terms of simply the people creating the models, which are the people that the most fame and fortune, of course, but the types of maintenance and invisible labor that is involved in the maintenance and perpetuation of particular AI artifacts. So this builds on a research agenda which we call the genealogies of data, the kind of founding document which we published in 2020 in a paper called Bringing the People Back In, contesting AI benchmark machine learning data sets. And in this, we talk a little bit about the different ways in which data sets operate as a type of infrastructure. In this paper, we draw very much on infrastructural studies from science and technology studies, on which thinking about how infrastructure operates in the world. And in this paper, we talk about four. But most notably, I want to talk about the way in which these data sets operate as a way of structuring ontologies of data sets. So in the case of ImageNet, the way ImageNet was created, in a word, is that the creators of the data set scraped image search engines in the early, or rather the late 2000s, in the early 2010s. In that era, it included Google, but also AltaVista, Lycos, Yahoo. Then took the words in which they searched from WordNet, which I will speak about in a second. Then had thousands of human annotators search through these images, confirm or deny whether the images actually met the criteria of being included in the data set, and then published from there. One of those consequences is that the images in the data set work in a very particular way. They are a function of what kind of images are on the, were on the internet at that point in time. So in that case, many of the images were coming from public image boards, companies like Flickr, or individual sites that were indexing individual amateur photographers. Nicholas Malev, for instance, has an article for Unthinking Photography in which he talks about the ways in which particular sorts of words are represented in these images. So in particular, we see hammerhead sharks, typically in the wild, characterized as scientific objects, trout as dead trophies, and lobsters primarily as food. There's also a particular computational construction of meaning and understanding in the way that ImageNet was created. Not the idea that images are diverse and feature and should feature different types of contexts in which these images may be located, but that there is a one way of viewing a particular object. We call this in the paper published in Big Data Society a computational construction of meaning and understanding, as if there's a direct one-to-one understanding of what an image is and what it represents. So, this is, of course, is not the idea of images. There's whole fields of study of images, such as interpretive semiotics and art history. We can think of the famous Magritte, this is not a pipe, the kind of idea of what images are meant to represent. But this direct mapping of what's in an image is taken very seriously by Dr. Feifei's lab. In this case, this screenshot taken from a slide in that as being this eye has this godlike view of having a sky in the sclera and an iris made of a camera lens with the somewhat ominous, quite an ominous image with the logo to build computers that see. So where did the words come from? Where did the ontologies come from in ImageNet? They actually come from WordNet. And in the story presented in the introductory slide, the article by Quartz, the way that Dr. Lee tells this, or Dr. Feifei tells this, I use Dr. Feifei as a preferred, this is typically how she is cited in text. The way that Dr. Feifei tells this story is that she met the maintainer of this data set called WordNet when she was at Princeton and was a young faculty member. WordNet, as described on their website, is a large lexical database of English nouns, verbs, adjectives, and adverbs are grouped into sets of cognitive synonyms, each expressing a distinct concept. And so in this way, we can think about WordNet as a type of a dictionary, and instead of a dictionary that's being organized alphabetically, one that is organized into these cognitive sets. The way that Dr. Feifei tells it is that she met with Christine Feldbaum, who was the maintainer of this project. Feldbaum told her about a potential way of indexing images and hence then ran with the idea and said, well, we need these images for doing things like having a database in which we can use for AI applications in image recognition tasks. So just to give you an idea of what WordNet looks like, I'm taking this category which occurs often in ImageNet papers, which is Pembroke, Welsh Corgi. You can tell from this kind of hierarchy here, in which Pembroke, Welsh Corgi inherits from Corgi, inherits from dog, inherits from canine, carnivore, placental, mammal, vertebrate, chordate, all the way up to object, and then finally entity, which is the root of all objects. So thinking through this, I'm wondering, where do the words actually come from in ImageNet? And when you ask this on WordNet, they say, well, our lexicographers write them. And then you say, okay, where did they actually come from? And they give you a much longer answer, and digging into this text, you can see a description of the different places in which these come from. So initially, the words came from the Coursera and Francis Standard Corpus of present-day edited English, which is informally known as the Brown Corpus, developed in the mid-40s and 50s to study some initial computational linguistics. They then adopted elements of the Brown corpus, which they sold the parts of speech tagging in the Brown corpus to Holland Mifflin. So then they had to they could still take the words, but they couldn't have the part of speech tagging. They then asked Charles Osgood, another linguist, about some words he had. They then consulted various thesauri, including Roger's International Thesaurus in 1977 edition, including many other people at ONR, Fred Chang, and then a few different folks at NYU. I've spoken with Christine Feldbaum before. She effectively said they don't really have documentation about where words actually came from. In that case, they were chasing down whatever words they could. Brown's corpus still has some reasonable documentation in it. If you go to the website, in the Brown corpus manual, misspelled on their website, not my fault, you can see lists of samples of what's in the data set. And Brown's corpus being constructed at the time in the mid-50s includes political reporting, including from newspapers such as the Atlanta Constitution, Chicago Tribune, some texts, specifically Christian literature, including William Porton's Physician and Christian, Schubert Ogden's Christ Without Myth, Edward Kelly's Christian Unity in England, and several different texts of the time that had to do with kind of self-help and pop psychology, including Alice Ho Austin's Let's Discuss Retirement, Harold P. Winchester's What It Means to Be Creative, and Marvin Centaur's and Stephen Holt's How to Have a Successful Honeymoon. In particular, you could access this stuff. I mean, if you go to the NLTK, which is included, I think, in you can do a pip install install NLTK. You can type nltk.download, and then you can download these in any. And I did this just last year. It's still in there. A particular text that I'm fond of is Who Rules the Marriage Bed? So this is, the first way this starts is in tradition and poetry. The marriage bed is a place of utility and unity and harmony. The partners each bring to it unselfish love, and each takes away an equal share of pleasure and joy. At its most ecstatic moments, husband and wife are elevated far above worldly cares. Everything else is closed away. This is the ideal. But marriage experts say that such mutual contribution and mutual joy are seldom achieved. Instead, one partner or the other dominates the sexual relationship. In the past, it has been the husband who has been dominant and the wife passive, but today there are signs that these roles are being reversed. In a growing number of American homes, marriage counselors report the wife is taking a commanding role in sexual relationships. It is she who decides the time, the place, the surroundings, the frequency of the sexual act. It is she who says aye or nay to the intimate questions of sexual technique and mechanics, not the husband. And so in this case, we're thinking about these kind of elements, these types of places, and which mining of the words comes from to build modern AI, and somehow has this tenuous connection to a text from the 50s deciding who should be the top. And this can explain kind of where the weird ontologies of ImageNet come from. In 2020, artist Trevor Paglin and AI researcher Kate Crawford published on a page called excavating.ai the weird different ontologies in the ImageNet dataset, specifically in the person subclass. They found many different odd categories, including amongst them terms like closet queen, ball buster, sloth, lazy person, all kinds of negative connotations, amongst which had images of women that had no kind of unifying theme, kind of images of men, things that should be mapped to people somehow, but had no connection. If you go into WordNet, you can look up this term closet queen, which they define as a negative term for a homosexual man who chooses not to reveal his sexual orientation, which descends from homosexual, which descends from person, organism, all the way back up to entity. So this ontology of ImageNet, these work of lexicographers, has gone somewhat undefined, somewhat undocumented, and yet had been, at least for 10 plus years, used in the development of some of the most critical AI technologies at the time. and still is used quite often today. What does it mean for the practice of AI and the work of building upon these tools? The next thing that I want to highlight, and I think this tends to have received more attention, thankfully, these days, is the work of data annotators, and especially the data annotators that were involved in the creation of ImageNet. And so this section is titled, Humans Emerge Only in Times of Great Need. In a talk by Dr. Fei-Fei Li in 2017, a retrospective entitled ImageNet, Where Have We Gone, Where Are We Going? She talks about the army of labor used in the construction of ImageNet. So remember, we need some verification of the images in ImageNet, whether they meet the criteria of the word in the ontology. In her telling of it, Jia Deng, another PI on the project, who was a grad student at the time, now I believe is a faculty at Princeton, had done a back of the envelope calculation. It said, if we're going to use Princeton undergrads to actually code this thing, it's going to take us 19 years. We have 20 million images. There's no way an individual can actually look at the data set in this particular way. There's actually I'm in the process of looking at ImageNet myself too, and it's weirdly running into technical difficulties just even loading this on the cloud machine without spending a bunch of money a month. Anyway, if anyone has any idea of how to render a bunch of images, I'm happy to, like on a remote machine or even locally, I'm happy to talk about that too, because I just want a way of looking at these. In any case, the way that so they couldn't use Princeton undergrads for this. So they said a godset appears. It was quite recent at the time, but this notion of crowd work was still pretty new. And Amazon Mechanical Turk emerged as a potential solution for this. So they were able to say, on demand, we can get people to do these micro tasks, recognizing what's in these images, actually telling us what's in them. And so they bragged. We have 49, they used 49,000 workers from 167 countries from 2007 to 2010 to actually verify what was in these images. Kind of trying to say, was this actually a kind of a mode of drudgery? Also in this slide deck, they asked, well, are we exploiting chained prisoners? Is this just work of drudgery? And they actually say no, actually most people don't do this full time. They're doing this for extra money. They use some data based from an NYU faculty member that illustrates the kind of a survey of US-based ImageNet workers. And they even say the 2008 economic slump, maybe ImageNet helped us get out of that. Kind of poking fun at this, artist Mimi Anuha presents this on its head. And this is where the title of this section comes from, Heroes Emerge Only in Times of Great Need. If the kind of saviors of science or the saviors of engineering are these AI people, the foot soldiers are those who are those annotating its data. And in this artwork, she presents the kind of rumpled living situations and working situations of individuals who are involved in this. So this is the couch. This is the the computer lab. The kind of places where people crowd in to do this micro work. And yet these are the people who are are fueling AI for the future. And here I want to shout out one of my former students, Mila Michelli, and Adio and Danica, who are doing this work on doing a workers inquiry with workers in Bulgaria and in Kenya who have done incredible field work and actually speaking with data workers and highlighting their concerns. In terms of just the kind of resistance to this and kind of responses by data workers, I want to highlight a project, Shirhathacon, which does give us some insight on what this work was actually like. And I'm in the process of interviewing workers who also worked on ImageNet. I was surprised I could actually identify workers who worked on ImageNet. This was a project that occurred, it started 20 years ago nearly, and people still remember these human intelligence tasks were called hits. On Turkopticon, Turkopticon originally started as a tool developed by Lily Irani and M6 Silverman, which was a way to actually rate the raters, or rather rate the requesters, having a way to actually say if they were communicative, or if they paid on time, or how were they going to reject your work without any kind of recourse. It has now become an organizing project since 2019 with staff, a lead organizer, and people that's involved in organizing workers together. When we actually go back and look at the data that's available on Turkopticon, which there's a little bit of data, there's some data about the requester themselves, the ImageNet requester. It's not clear whether they're about the ImageNet construction task. They're pretty uniformly terrible. The first one reading, play a game of identifying birds and get paid, and look at car images and identify cars. Both of them awful, underpaid. I think this requester is mocking us. I just did 2 hits, but no way to continue wasting so much time for him. The second one of the all-time worst requesters on AMT has changed their requester ID to run from all the negative reviews. Do not be fooled. This is the same ImageNet AMT. See the other profile for real reviews. And then, wow, they expect you to do 6 pages of tedious work, identifying specific years and models of cars for 5 cents. I started working on one and returned it after I already wasted 10 minutes on their qualification test that is included with your first hit. In Dr. Timney Jabrew's dissertation, which was on, among other things, determining neighborhood median income from the makes and models of cars, she said how the task was actually quite difficult for AMT workers, quoting AMT reviews on Turkopticon. Apparently, the virtually indistinguishable cars are super indistinguishable to them, and this, she cites the kind of distinction between a Ford F-150 XL and a Ford F-150 XLT, trying to determine the difference between these cars on Google Maps. Obviously, you can't tell the difference. And then again, I paid very close attention to the pictures and let the requester know that I feel like these rejects were unfair. We'll update as soon as I get communication back. So this is the place where we probably know the most about the types of labor that are used in the development of these data sets, but also the ones in which there's probably efforts and some of the most silence coming from different annotation companies. For an example, oops, I think there was like an update or something. So I think this is taking the focus off. Thank you. There we go. Thank you so much. So I do want to give a shout out to a campaign that Turkopticon has been running for over 4 years now, which is about mass rejections. Right now on the platform, Turkopticon effectively, or mTurkers effectively can do a whole bunch of work for a requester. That work can be rejected unilaterally without the requester explaining anything about it, and the workers have little to no recourse on this. Recently, also Amazon Mechanical Turk suspended probably hundreds of individuals. We know of 35 of them, 34 of them, and suspended them for the platform for no reason after 2 weeks of constant pressure, including pressure from allies in Congress. That decision was reversed. Amazon gave no explanation to this at all. And if these are the folks that we know about, there are likely hundreds more. Lastly, I want to talk about the data subjects in these data sets. And I call this section being a data subject in Dataful Times. And it's about what I think the amount of what it means to be someone who's included in these data sets with little to no knowledge or little to no oversight. And so an indicative situation happened kind of as a response to increasing literature on fairness and attention to facial recognition. IBM released a diversity in faces data set to advance what they called the study of fairness in facial recognition systems. They said, we're releasing this as a benchmark upon which you can test your different facial recognition systems. Soon after their release, Olivia Salon at NBC News, who was currently at NBC News, published an article, Facial Recognition's Dirty Little Secret, Millions of Online Photos Are Scraped Without Consent. Of course, this is kind of du jour in facial recognition research and object and image research. However, this was reporting in particular on the diversity in faces data set. So prioritizing diversity without focusing on consent and what it means to be in this data set. Kashmir Hill has also reported on this, particularly on the data set Megaface, and she has a great book, Your Face Belongs to Us, on Clearview AI and the questionable scraping they've done for their facial recognition project. Not JD Vance, excuse me. That is someone completely different. I thought Vance and then went to JD. Thank you. Stephen Vance filed a lawsuit in Illinois court under the Biometric Identification Protection Act against IBM in particular, notably on the potential for surveillance. So subjecting them to increased surveillance, stalking, identity theft, and other invasions of privacy and fraud, specifically on diversity of faces data set. And other organizations are potentially open for this potential suit. Even going back to excavating AI, Michael Lyons, a computer scientist and psychologist and artist, criticized Kate Crawford in the Excavating AI project, effectively saying, the ImageNet results are one thing, but the Jaffe data set, in particular the Japanese affective face expression data set, was displayed on these exhibitions in Prada Mode Paris, in different locations, of using these Japanese actresses' faces without their consent. Ostensibly to make a point about the use of one's faces without consent in the data set and the kind of faking of faces, expressions rather, and still without consent. In reading a particular data set, Everest Pimkin, artists and computational, I don't know how to characterize Pimkin, I would say artist, in an artistic work that they developed called Lacework, they ended up watching an entire data set. In this case, it's a data set called the Moments of Time data set, in which they had watched 3-second clips taken. I think this one was developed by Microsoft, and had identified kind of the act of watching this data set and what was going on in it. And in it, they remarked they didn't plan on watching this entire data set. They ended up watching 1 million 3-second clips. I don't know how long that took them. You can do the math on that. And found themselves feeling very voyeuristic, and was looking into effectively the violence of the data set. They remarked that they saw intimate moments, crying, they saw people die, they saw moments of questionable consent. And you can imagine this exists in all image data sets that fuel generative AI tools, that fuel image generation, now video generation, and whatnot. And I want to conclude by saying what I think this all points to is that the notion of labor involved in the construction of these data sets is not only on their construction, their verification, but about how they undergird how this data set's been created, how it's maintained, what types of fictions need to be maintained for this to be an artifact that exists in the world, and what does that mean for AI development writ large, and what does it mean for these tools and the people maintaining these tools. I'm not quite, you can tell probably from my voice, I'm not quite settled about what this means. And this is why this is kind of like an open invitation about thinking about cultural labor and these data sets. And I think this is, and I ask this because this question is really gnawing at me in such a way about what does it mean to sort of enact this at different types of labor at different moments of data set creation, maintenance, and persistence. I'm going to leave it there. That's my details. Thank you so much. Happy to chat more a little bit after the talk and then email after. But thank you.
Thank you so much, Alex. So,
Yeah, I mean, that's a really good question. And I think benchmarks are effectively centralized because the work involved in putting together data sets is very undervalued, for one. In computer science as a discipline, it is much more impressive to develop a model that uses sophisticated engineering than to do the crucial work of understanding, of collecting data, of potentially removing biases from it, potentially removing awful images from it, like CSAM. And I think that is the data sets that exist. It is very risky to go ahead and actually create a data set like ImageNet. I actually focus on ImageNet kind of obsessively, not to attack Dr. Fei-Fei Li or Jia Deng or Olga Rosakowski or any of the PIs on the project. They've actually done the best documentation on this data set because of their positions at Stanford and Princeton. And it is more the case that developing a data set as a resource is a very risky professional enterprise. So in that Quartz article, for instance, Dr. Fei-Fei talks about how her position as junior faculty and as a woman really did not, like, people are saying, why are you doing this? You should focus on building models. Building a huge data set is career death. Okay. And then she stubbornly kind of went on, developed a data set. And it was a risk. It was high risk, high reward. In the kind of data sets that we see, and this might be changing in sort of generative AI, for instance, the Lion data set is a data set that was developed, I think, by a German company that I think is not primarily academic. The Pile data set, which is a data set of text, was constructed by a research collective called Ultherd AI, and they're developing a second version of it. Common Crawl, which there's a great report that was written by Stefan Bach at Mozilla, is a nonprofit agency that had developed this and then just became very, very popular as someone seemed to stumble upon it and use it for major training of initially GPT-2, and now pretty much every data set relies on it. So I would say that in the time of its adoption, ImageNet has become such a paradigmatic data set because of the lack of investment in data set work. I would say there's institutional elements which are changing about that. So for instance, NeurIPS, the largest machine learning conference, now has a data set and benchmarks track upon which data set development is encouraged, and professional kind of accolades are rewarded, and that is a positive thing. And yet, adoption is another thing. Adoption is still overwhelmingly in in ImageNet. Why people aren't switching to different data sets? That's an open question, but at least the kind of answer I have of why other image data sets are not created, effectively because there's little institutional incentive. Yeah, great question, right? I mean, it's kind of all of the above, right? I mean, MTurk, I'd say that work is probably moving more away from MTurk and to other organizations which are based in particular countries of work, typically subcontractors. So one of the examples that's gotten a lot of press lately is SamaSource. So SamaSource is a company that OpenAI had been working directly with and had a contract with them for a number of years. Time magazine had a large article on how Kenyan workers were receiving $2 a day, effectively doing content moderation and red teaming of these tools. They cut that contract off, but still need to do this work somewhere. Some of these, typically, this is the same kind of institutional arrangement that they have with content moderators, depending on what they're looking for, right? And this tends to be different. So if it's hate speech, you might have things which are a little more local, but again, hate speech removal is very tuned to particular languages and to particular contexts, right? And it is vaguely under-resourced in Africa, in Latin America. And you can see some of the initial reports that have come out due to the Digital Services Act, which determine, basically you have, something like 4 content moderators in Tigrinya or in Amharic, and then you have 10 content moderators in Arabic. So there's very few content moderators, but the work looks very much the same in terms of institutional arrangements. If it is involving CSAM, that tends to be in-house, or not in-house, it tends to be in America or in the US because they're kind of the strictest CSAM regulations. It has to do with violence. It is often done, in the Philippines or in Venezuela or Kenya. And so they are typically at enough of a remove that they are contractors or subcontractors, typically not done in-house, but they might be the only client of a particular organization. So I mean, it's the same arrangement. I mean, I think less of the work that is done in large models typically goes to MTurk or Prolific or remote tasks, but some of it does. Typically, they're organizations that have that people sign up with in particular that target a particular country and contract to particular language model or image model creators. Yeah, but it's also not really clear. I mean, there's different arrangements. The World Bank, I think, estimated that there's something like 150 to 500 million data workers worldwide. There's just wild estimates on that. I mean, that stat itself is really hard to verify. Yeah.
I think on behalf of everyone, on behalf of Prince and Metrics, thank you so much for taking the time out. This was such an amazing talk. So many thoughts, so many questions. I think let's join hands and thank you.
Thank you.